Okay, hello guys. So if you have been following so if you have been following me on Instagram, I just wait a second. So if you have been following me on Instagram, you must be knowing that I am doing a 1 week of Python challenge, which I challenged myself. So yeah, basically this is day one of that challenge, and I took up object-oriented programming and learned it in about a few hours. Okay, so not to brag, this challenge, the basic goal of this challenge is to make you believe that if you know one language, nothing can stop you in switching the languages. Okay, so most of the beginners, text me, DM me that which language should I pick, which language should I start with. So there's not one language. You choose C, you choose Python, and that absolutely doesn't matter. Yeah, well, if you have a goal set, like if you want to do app development, then choose Java. If you want, well, this is not a video about that. Basically, I just want to talk about what I learned today. So let's take right ahead. Okay, so here's some summary of what I learned today. So this one, class is a blueprint. We will see all of this in code in just a minute. Okay, and this one is a little diagram I tried. yeah, no Photoshop, simple text diagrams. Okay, so yeah, if the time suggests, we will see the bonus also, but let's just forget about it till the last of the video if we have time left, less than an hour. Okay, so I learned the basics of class and objects, basically object oriented programming, and one second. Okay, and the four pillars of object oriented programming: encapsulation, abstraction, inheritance, polymorphism. This one is really tricky, and I don't know if I had grasp on it, so let's check that out. Okay, I think I already forgot it. Just kidding. Okay, so basically this diagram shows what a class is. Basically, class is like a, I don't know, blueprint of object. Okay, so a class is basically a definition. Okay, so a class has properties and methods, and with the help of class we can initialize or instantiate objects. Okay, instantiate objects, or these are also called instants. So with class we can instantiate instants. Okay, and all of these instants are different instants, as here class is a blueprint of objects. Basically everything is Python is object. Please keep this in mind. Everything is in Python is object. So we can instantiate multiple unique object from a single class. Okay, so now let's just quickly see this in code. By the way, all of the properties of the class, each object have that property. So let's just say that we want to make a class, let's say human. Okay, we're gonna init self. What this is, we'll talk about it in just a minute, just a few minutes. Okay, so a human should have a name, a human should have age, a human should have, I don't know, I'm not a racist, so I'm not gonna add anything about it. So a human should have name and age. So we'll say self dot name equals name, and self dot age equals age. Now we can add basically method are basically, okay, properties are variables which, like this name and age, are properties of this class, human class, and methods are the function of the class. Why it's called method is these are called method just because it is attached to a class. Okay, make sense? Okay, that's why it's called method, nothing else. So we're gonna fed not def, yeah. Def, let's say walk, really simple. Self, okay, self is basically referring to this class. Okay, so here init is a way to initialize an object. Okay, so whenever we will make the object, this method will be called. Self is referring to this, so self will be an argument which will be passed itself. Name and age we will be passing. Okay, now let's see, print, I'm going to use a f string. I'm going to say self dot name is walking. Okay, let's just quickly create object. Okay, so arpan equals human. Okay, so this is giving us error. Why is that? Well, that's because, okay, that's a lot zoomed in. Okay, this is giving a red line, if you can see, which is an error. So basically this is accepting, this wants us to, whenever we initialize this object, any object from this class, it wants us to pass name and age variables basically. Okay, let's just quickly see. Arpan age will be 20. Let's save this and the error is gone. Now let's run it. Python 3 out.py. What the humor? Okay, human, sorry about that. And yeah, well, we didn't do anything, that's why. So let's arpan dot walk. Okay, yeah, arpan is walking. Actually he's sitting, but arpan is walking. So what happened? Okay, so arpan is an object which gets the property and all the method defined inside the class of human. So now arpan is a human. Okay, let's see this. Print type arpan, let's see, class main human. Okay, basically class human. Yeah, it's a type of human. Now okay, that's one thing. So basically we talked about class is a blueprint of objects. Basically human is a blueprint, and we can make several other blueprints like Abhishek, which is my last name. Let's keep that a small. Well, it's naming convention. Class, first letter of the class is capital, and variable we Python if you. Okay, let's make Abhishek. What the hell? ABHI SHEK Abhishek. Let's make I don't know, Biraj. Again, what's wrong with me? Okay, control D, BIRAJ. Let's make I don't know, Ankit. Okay, D and Kit. Okay, now each one of them have same property, name and age, but all of them, well, in this case age is 20 because I didn't change, but every one of them have different name property. So even if the blueprint was same, all of them have different values for the name property, and this is really cool. So you can make as many human as you want, but they will be unique. And if you see, I don't know if we'll be able to do that. Wait a second. Print arpan. Let's see what we get, okay, we get an object at this. Okay, let's print all of them just to confirm that they are different, indeed different and totally different. So Biraj, Ankit, let's see, let's print it out. Okay, so yeah, I was shocked when I see this one. Okay, so you can see till here the address are same indeed, but after that 320, 358, 390, 3C8. So all of them are at different address. That means they are not referring to a same object, but they are indeed different objects, which is really cool. With one blueprint you can create multiple objects which can have multiple different properties, and well, possibilities are great and you can have fun with it. But right now I'm not gonna, sorry about that, I'm not gonna do anything. I don't know. Okay, so let's talk about something. So what happened when we did this? Okay, so this called this, as you can see, these are the arguments that this is accepting. Basically init initialize or instantiates the object from the class. So basically we have to call the class with parenthesis and pass the argument which this init function expects. You don't need to have a init function, by the way. We can comment it out and we can say human, because we commented it out. Okay, since it is not there, we do not have access to the name and age. Basically, if we want our object to have properties, we need to have this in it, so that we can at the starting, at the runtime, we can give the objects properties. But since we do not have init in this right now, so this will not be this will not have the access to that. Self.name. Okay, it's too hot in here. So arpan.walk. Okay, let's just print it out. Oh, sorry. Let's comment that. Let's comment them out and remove this. Since we do not have init, it's not expecting any parameters. So yeah, human is walking. Let's clear that out and print it out, and human is walking again. Okay, so basically we saw what init is, what basically okay, so object oriented programming is just a paradigm to write code, basically a format to write code, a way to write code, procedural format. You write everything in a procedure, right? You have variables, then you have if else statement, then you have loop, and the compiler or interpreter, in this case in Python, reads out line by line and executes. Basically that's procedural. But in class, you can work as a team, and you can divide the ways. Like if you want to build a machine, okay, so someone is working on another part, someone is working on another part, and then you can combine all those parts. That's object oriented programming. That is really I don't know how much really I mean really powerful. Okay, so we covered this, we covered this, we covered this, we covered this too. Now comes pillars of encapsulation. Actually we already saw these two. Okay, encapsulation and abstraction we already did. So what happened when we created our class? Let's pull it down. created our class. Okay, so let's give here self dot name. Okay, so now what happened when we initialized or instantiated our instances? What happened? Okay, so what I said, every object is encapsulated or different from each other. Encapsulation is basically I don't know how to explain it. Let's just Google it simply. I'll open Chrome and I mean Mozilla Firefox, not Chrome, sorry. Encapsulation. I'm not getting word, seriously, I'm not getting word. Encapsulation in Python, or encapsulation meaning, oh, okay. Encapsulation is packaging of data and function operating on that data into a single component and restricting access to some of the object's component. Okay, means the internal representation of, basically, okay, this is abstraction and encapsulation together. Okay, so encapsulation basically means these are packaged differently. Okay, you get the idea, right? I'm seriously not getting the word, but basically these are differently packaged. Like I said, for the machine, okay, different parts will you can create different classes, and those classes are also different from each other, and all of the properties are encapsulated in those class only. You cannot access this class object cannot access the properties of that class. You're getting the point, right? In unless those are interrelated, and which we will talk about here. So that's encapsulation, packaged in privately, secretly. So abstraction is basically abstraction is basically, I'm again not getting word, I'm so bad at it, but I'm not gonna Google it this time. Okay, so abstraction is basically, okay, let me give you an example. When we call walk on Arpan, we user do not know what function he is calling. He just knows that if I call walk function, I'll get what I want. Like it's saved, right? Yeah, Arpan is walking, he'll get Arpan is walking. Okay, he does not need to know what is going behind the scene, what is happening inside the class, and that is abstraction. The user who is using the function does not need to know how the function is built. That's abstraction. The layer of abstraction, you must have listened. The layer of abstraction, you just need to know that how this works. You do not need to know how this is built. Like you basically, let's take an example of car. Okay, you're riding a car, you just need to know how to steer the wheel. You do not need to know how the steering is steering the wheels, or controlling the wheels, or how his engine is working. You do not need to know. You just need to know how to work with it, right? So that is abstraction. You need to know how it is working. Oh, sorry, you need to know how to use it. You do not need to know how it is working. Okay, so these two are done. Inheritance is basically, as the name suggests, is like you inherit some properties from your father and mother. So that's inheritance. So let's do that now. I don't know, I'm not getting in example. Okay, let's just take father and son, or mother and son. Class father, let's init it def, or let's just don't init it def. I don't know, walk. Every father should walk. I don't know should, but can walk, okay. Print walking. Now I want to make another class, son, and to inherit the properties of father we have to pass an argument father, the class we want to inherit from. So this we can init. Basically we can init that also, but we don't want any properties, we just want the method to inherit. So that's why self, and we can say a name, we can say an age. So let's see, self dot name, self dot age, okay. And now let's def, okay, let's not def, okay. Let's see here, and if you can see, we can instantiate son, like I don't know, Gerard, I don't know if that's correct spelling or what, but we will initialize it with Gerard, and age, let's see, 10. Okay, now if we go to Gerard and press start, now let's see, we get age, name and walk, but we do not defined here any walk is here, right? So basically it is inheriting the properties of parent class, parent in this case. So if you call walk, walking, sweet. So but there's something more in this, and I hope I would be able to explain it. Def init self, okay, name, and age, and let's see, okay, self dot name equals name, and name, and self dot age equals age. So there's no point of doing this here. So what we can do is we can call father dot init, and we can pass name, age. Hopefully we can pass this, I don't know. Hopefully we can do, okay, syntax error, I thought I will get it. Okay, we did, okay, that was not a logical error, simply, self dot name, indentation, okay. I'm thinking about the logical error. If I guess we got missing two required prepositional argument, name and age, type error, okay. Gerard, line 1, init 41, line 41, what's line 41, father, okay, let's see, let's pass them here. Let's see if name, age, looks like I forgot it. Okay, so let's check if let's check if that's working. Self dot name, okay, this won't work, we have to give it here f, okay. Okay, finally let's check. It's not working. Sun has no attribute name. Okay, Sun has no attribute name. How we can do that? How we can do that? How we can do that? Okay, we called that. We have to, I guess, give here too. Okay, I get it. I wanted to tell you about super, but I think I'm not able to use it here. Python is a little tricky, man. Name, age. Okay, let's quickly search for it. How to super in Python. Let's quickly search for it. And yeah. Okay, this is a class computer. I hope you can see it. Wait, yeah, so this is a class computer. It has an init, okay, super, just called super init computer RAM storage model. Okay, we could call, I guess we reached it there. I guess so. We reached there. Super, we just have to delete these and super these. Guys, we did that. Whew. I think it should work with that also. Why isn't it working? I'm not getting it. I have to see it. It's not working. It's not working. Okay, let's keep it. We have super. So basically super is a keyword which calls the constructor of parent class. That's all. Okay, it calls the constructor, or in this case init, of the parent class. So when suns run, so it will call super of that class, and it will have the property name age. So it will also have the property of name age, because it's parent, it's child class of that father. And now we will initialize this sun with name and age, which we will pass here. So if we call walk, even if it is inside the father, we can call with the sun class. That's inheritance. Okay, and that's super. Well, that's a little complicated in Python. You can easily do that in other language, but we are doing a week of Python. We have to face errors. That's how we learn. Okay, polymorphism. Okay, polymorphism. So to do that, I want to do something different. Okay, let's define a function called fight, because children fight. Sorry. Okay, fight, and we will say self, obviously. Super. Oh, super. Sorry guys, my phone is disturbing me. I dropped it. And now focus. Print. Let's use a f string, and let's say self.name is using, I didn't talk about polymorphism, but we are using a example of polymorphism, and I will explain what it is after this example. Okay, so don't sue me for that. Oh, it's just half an hour. I guess we can talk about this. And now I'm scared. Okay, is using okay, is fighting techniques. Okay, we have a lot of time. Let's talk. Let's search for fighting cool fighting techniques. Don't leave the video, please. I got you. Apni the okay, nutcracker choke. Okay, is using is using nutcracker choke. Okay, now let's make another class, and this will be DAUGHTER daughter, and everything will be same, and we'll just change the fight method, and we'll say axe stomp to whatever. I don't even know what this means, but okay, let's go with it. So Daisy equals daughter Daisy, and let's see, elder sister. Okay, now we can say fight, and wait, we know that both of these fights are different, right? That's because of the encapsulation. Each of these fights are different from each other, right? But what we can do is we can define almighty Friday. Okay, what we can do is we can call no, wait a second. Okay, let's say for child in, let's make a list of Gerard, Daisy, and we can call child dot fight. So by calling just one function fight, we can access both of these. So what is polymorphism? Poly means many, morphism means form. So polymorphism simply means that you can use one thing in different ways, in different forms. Okay, so there's not one right way to use it wherever you want. There's no book which you can which can tell you where to use what. You have to decide that, and that will come with practice, and I don't have that practice. I'm a noob, so I'll do practice, and hopefully in this 1 week I'll get better at Python, hopefully. So yeah, and for the bonus, should we do it Thunder method? Well, I should have taken the name. This one is dunder method, or you can say like dash dash. These all are dunder methods, or wait a second, object dot dash dash. These all are dunder methods over this object. Object basically is object from where all the object is a class where all the object, I told you at the beginning only, everything is Python is object. Okay, so object is the most parent class from all, all of the classes are derived from the object. So even if we are not passing anything here, object is there. So if we do that, nothing will change, okay, because that's natural. Okay, that's how Python works. So basically, okay, we can check something cool here, like I should have done that in inheritance, let's say print Gerard, okay, is instance. Basically it checks if the object is an instance of. So if I say Gerard and I say class son, so it should be true, right? It should be true, yeah. And if I say daughter, it should be false, right? It's false. And if I say father, what do you think? Think. I cannot ask you. True. Yeah, because Gerard is inherited from the father, so it is an instance of father, okay. And object, if we check object, we get true, because everything in Python is object. Okay, list is an object. It is indeed. Dict, I don't know if it's dict or, yeah, dict is an object. Indeed it is. You get the idea now, right? So should we talk about tkinter method? Tkinter method are basically method which are defined to, like this, okay, print I don't know, length, okay, str, let's say Gerard, okay, it prints the Gerard in string form, okay, the object, definition. If we go up here and redefine the string function, we would say str self, we would say return, I don't know, return changed it, you fool, haha. You see this? So basically these tkinter functions are used to create the basic, functions of this. If let's see if it does, if we say length, we say length of anything like 0,19, okay, so it will return, obviously this has no length property, but if let's comment it out and let's see the length of this, so it should return 2, right? Oh, we did not print it. Okay, so print, God, what am I doing? Print length, it turns 2, right? So if we define, if you want to define, so we can define, let's change it to len, and let's return 1000, 10,000, it's 10,000, 10,000, okay, that's 10,000. A moment ago you saw it threw an error because nothing was len, right? And we know len is a function or method defined on lists by the Python. We do not have to do anything, which returns the length of the list, and now our class son has a length property, okay. So this is pretty stupid to do that, this one. So but tkinter methods are really helpful, you can say. Tkinter methods are magical, or you can say anything you want, but yeah, tkinter methods are pretty powerful. So this one bonus done. Multiple inheritance. So now comes the mother. let's make mother self, name, age. Okay, and okay, mother also. We can give mother here also, super. And who do you think should be, favored among these two? I don't know what's gonna happen. Son has no len. Okay, let's see, walk. Gerard at walk. Let's see, Gerard walking. Okay, but let's see from where it's coming. From father or from mother? What do you think? I haven't tried it before. I know there's multiple inheritance in Python, but I haven't tried it before, so let's have some fun. Let's father. Why only father? Why not mother? You tell me. Now here should come the, I don't know, the father, name, age, and actually these two will probably conflict with each other, so I'm gonna change it. And I'm gonna say, let's see if we can do this. Let's see if our code breaks. Has no attributes name. Son has no attributes name. Okay, so we have to call init, obviously. To do that, we have to check if name and age, okay, it should work. Has no attribute name, so what, we have to call self also, or just this, I don't know. Okay, let's Google it, because I'm not leaving it without learning. Okay, so multiple inheritance in Python. Okay guys, now I think I have got it. So what we have to do is we have to call mother, and we're gonna pass self, then we're gonna pass name, actually just hair color, because mother just takes hair color, and father init self, name and age. Whew, I guess that works. And what, actually this is gonna conflict with this and this, right, from father only. So basically we have solved the problem of initializing, which we had first, so we don't have to call it, we have to call this way if we are not using super. And when we are doing multiple inheritance, we need to sprint, we need to say that we need to keep in mind that the methods and properties should not override each other, because everyone has importance, guys. Sprint. But the cool thing to note here is we were able to inherit property of two classes at the same time with the same object, which is also known as multiple inheritance. Wow, so this isn't well, you saw how complicated this can get. So this is why most of the language do not permit this, do not let you do this. And you see, this is just several lines of code, 2 or 3 lines of code. If you're creating a big application, a complex application, you're going to have millions of lines of codes. So just imagine how complicated it can get. So multiple inheritance, I see no point, sorry, but yeah. So MRO, method resolution order. Well, let's I don't think I'm gonna comment everything out, but yeah, till here let's comment out. And I'm gonna say here, I don't know what to say. MRO example. So let's see, we're gonna make class. Actually, we saw a class. I'm just gonna copy it. 1 second. Simply I'm gonna copy it. Yeah. Let's copy it. So this is, zoom out. Yeah. So from here it's starting class 1. So there are 4 classes. Class 1 is has a method which prints class 1. Class 2 also has same, but it prints class 2 and it inherits from class 1. So basically it is overriding the method of its parent. I don't know why it's inheriting then the only method it has, and it is overriding. So what's the point, man? So it is also overriding and inheriting from class 1. Now it is class 3, and class 4 is inheriting from class 2 and class 3, and it is also overriding class 4. So, and also it is calling class 2.m self class. Okay, let's see what. And we are creating an object of class 4 and we are calling object.m. So it should print class m. Okay, how did this work? Class 4, class 2, class 8. Yeah, simple. But I was talking about MRO. What the hell happened? Okay, let's see, and let's MRO. We have MRO, right? Let's call print on it. Print MRO. I hope that's so. Oh no, man, no, it should not happen that way. MRO, how to call MRO? Oh, too many errors in one day. No issues. Oh, okay, we have to call on class, I guess. Wait. I don't know, multi-derived. Hopefully multi class 4 dot MRO. Yeah, finally. It should not return anything because tuple is not callable. Wow. Okay, let's just okay, if it's tuple, so we'll just print out print, print, save it, and let's, okay, finally. So if we call a class m, any class which is conflicting, so this is how the method is gonna resolve. First it will call class 4 if it has if the class 4 doesn't have that method, you know, if we are calling, let's see, define mo self, and let's see, print class 1. Okay, and if we call object dot mo, so obj, what is happening now, what is happening? Okay, class 1 obviously, but if it would have, you know, this method will be here also and there also, then what should be called first? Oh wait, let me change it, class 2. Now what should be called first? Class 2, right? So MRO is basically the method resolution order, basically which method to call first if they are conflicting in an inheritance, multiple inheritance, right? So first, like it is followed, first class 2 is, you know, first of all class 4 will be called. If the method is not there, class 2 should be called because it is passed first, so class 2 should be then class 3, and since they both are inherited from class 1, so class 1 should be called basically. And ultimately, if that's not object, because everything in Python is object, so object will be called ultimately if none of them have, and if object also do not have that method, oh man, then you're gonna see an error. Okay, so too many errors tonight, tonight. So too many errors, too many concepts, and basically MRO is really advanced concept, and I do not know how it is calculated and whatnot. I just told you basic that this is called first, this is called at the last, because you know that's just how it works. Like if we do this, let's clear that out. If we do this, oh wait, do this, let's close that. If we do this and we say print m dot mro, then what do you think should be called first? B A Z A. Basically, if you want to see a diagram, this is how the class is connected. Wait, this is how the class is connected. M is the lowest, then A, B, and also Z. If you think, it's good. Wait a second. 2 minutes. Yeah. So this is how it's connected, and 2 minutes बोले ना, हम बजाओ नहीं ना. So this is how it's connected, and let's see. Let's check. Let's open our code editor and let's see how it's done. And if you can think, you know, oh wait, let's clear that out first, and let's see. First M, then B, like this, then A, then you might think then that should be Z, but that is X here, then Y here, then Z, and then object. I don't know why it is that way. I don't know how to calculate it. If you have you know, interest, please Google it and please tell me about it. For now, I am done with hopefully I'm done with object-oriented programming, and let's just git commit and push it. Actually, I'll push it. I'll just you know, is there a new file? No, it's not. So let's just commit -ma am, it doesn't matter, am, and let's see, revise OOP for day 1. And we are done, people. So that's it for this video. This video has gone way too long, and obviously my brother is out knocking the door, so I have to go. And obviously, peace out and share if you like it. Join me on Instagram to follow my hustle and bustle. So sorry. So bye bye.